hash map, and it's design this hash map without using any built-in table. So in this solution, when I saw this question, the first thing that came to my mind is having a hash map that is built with the index of the key and its corresponding value. And so um, it's built with the index of the key and the corresponding value. So we're going to have an array that can take in at least 1,000 elements. And after that, we're going to get the index of this key by doing the key modulo length of the map itself. Okay, the reason why we are using a linked list in the solution is because we are using something called hashing. Okay, so what's happening is that we want to have a key and a value, but the key and the value is going to be the index in the array um, to its corresponding value. And so the thing with this is that we can have a situation called collisions where we have multiple values that are meant to be in the same index. And so what we do in a situation like that is that we link it together. So we can be like value dot next, value.next, simply because it has the same index. And so right now, the first thing I did was I initialized a list node, which will have our key, our value, and the next value after that. Then I initialized my hash map, which was going to take at least 1,000 elements, right? So it has a list node that will take at least 1,000 elements. Then I used the hash function. This function is used to get the index of the key, so it can be used as the key in my hash map, right? So I utilize this function in all the three operations. So in the def function, I set my current pointer to my key, right, the index of my key, and then I said that well, there's another value after that my head, after my current pointer, if the value is equal to the key, instead of putting in a new key value pair that will be the same key, just append a new value. Then return it. If we do not have a cur.next, then set the cur.next to a new list node with a key value pair. Then in the next section, I'm trying to get my value. So same thing, initialize my current value to the head of, to the head, right, my index, which is the current value that I have. Then I said, well, we have current, right? If the current key is equal to the key that we are getting, return its value, right? If not, continue to go on, right? Cur.next. If we don't have the key at all, then we don't have the value, so just return -1. Same thing with remove. I initialize my cur. My cur was equal to the first key that I have in my linked list. Then I said that if the cur, if there is cur and there's cur.next, what we're going to do is that we are going to skip that cur and move it forward. So for example, if my values, right, if my key value pairs is 1, maybe 100 is matched to 1, then we have 2, then we have 3, 3, 4. What I'm going to do here is that if I want to delete 2, for instance, right, let's say I have my 2 pointers, right? Let's say this is cur.next, right? What I'm just use n. I'm just going to skip 2 and just assign the next value to 3. So that way 2 is already displaced and so it's no longer inside our linked list. So that's what I'm doing over here, right? If the cur.next key is equal to the key, then assign cur.next to the value after it so that we won't have to deal with that anymore. Or just do cur is equal to cur.next. So this is how I solved. If this is not the case, right, just do this. This is the base case of this problem. When I run it, okay, I have an indentation error. Oh, sorry. Let me remove these comments. Okay. So when I run it, it runs, it's accepted. So this is how I solve this. I'm going to